Let's go through this quiz about the different types of passive transport. I'm going to show you a picture of one of the three different types of passive transport, that being diffusion, osmosis, or facilitated diffusion. Remember that diffusion is when molecules move from high to low concentrations without energy. Osmosis is the movement of water across a selectively permeable membrane, again from high to low concentrations of water. And facilitated diffusion is again the movement of molecules from high to low concentration, but this is through a membrane protein. Here's our first question. You can see we have a beaker, we have some type of liquid and some barrier here, and you can see that this liquid is traveling from one side to the other. We're going to see that this side starts out with a high concentration of that liquid, and this side starts out with that low, but by the end, we have equal amounts on both sides. Since this liquid is probably water, this is osmosis, the movement of water from areas of high to low concentrations. Here's our next one. We can see we start out with these molecules. They're spreading out from a high concentration to low concentration. This is an example of simple diffusion. Here's our next one. We can see we have a membrane. We can see we have these things called membrane proteins, and we can see these molecules are moving through those membrane proteins again from high to low concentrations. Since we're going through these membrane proteins, this is an example of facilitated diffusion. Now this diagram might be a little bit confusing because again, we can see a beaker with water. However, it's not looking at the movement of water. It's looking at the movement of these dye molecules. And again, we're going from high to low concentrations, but we're not going through a membrane. The dye molecules are just moving on their own. This means this is diffusion since we're moving the molecules again from high to low concentrations until they reach equilibrium. Here we have our membrane, we have a membrane protein, we have molecules moving from high to low concentrations. This is an example of facilitated diffusion. Here's again, we have a beaker. We can see these dye crystals on the bottom. They're concentrated at first, but then they move throughout the container until they reach equilibrium. Now the water really isn't moving across a membrane, so this isn't osmosis, this is diffusion. This is a tricky one. We can see here we have water molecules moving through this barrier, through this selectively permeable membrane, and the solute molecules, example like sugar here, these solute molecules are not moving back over this membrane. So this means the water molecules are moving from high to low concentrations, which means this is an example of osmosis. In this image, we have our membrane, we have our proteins. They can either be a channel protein or carrier protein. Whenever I see those two terms, I automatically know this is facilitated diffusion whenever the membrane proteins are involved, especially when they say channel and protein. Channel just means they're not moving to allow these molecules through. Carrier proteins have to move to allow these molecules through. However, they're not still using energy. Whenever I see these U-tubes, I automatically think osmosis. And if we look here, we're starting out with a low solute concentration, high solute concentration. That means there's going to be a high water concentration and a low water concentration, which means the water moved from left to right here. And again, we're looking at the movement of water. That is osmosis.